Faults are fractures along which displacement has taken place. Faults in which the movement is primarily parallel to the dip or inclination of the fault surface are called dip-slip faults. Vertical displacements along dip-slip faults may produce long, low cliffs called fault scarps. To describe the displacement along a dip-slip fault, we use nomenclature that arose from miners who excavated shafts along fault zones. The rock surface above the mineralized fault zone is called the hanging wall, and the rock surface below the mineralized fault zone is the footwall. Dip-slip faults are classified as normal faults when the hanging wall block moves down relative to the footwall block. Most normal faults are small, having displacements of only a meter or so. However, precipitous mountain fronts have been generated over periods of millions of years by many irregularly spaced episodes of faulting. Other examples of fault block mountains are found in the Basin and Range province. In the Basin and Range province, the crust has been elongated and broken to create more than 200 nearly parallel mountain ranges. Normal faults indicate the existence of tensional stresses that tend to pull the crust apart. Normal faulting may also result in a central block called a graben, which is bounded by uplifted structures called horsts. The Great Rift Valley of East Africa is made up of several large grabens bounded by tilted horsts. Reverse faults and thrust faults are dip-slip faults in which the hanging wall block moves up relative to the footwall block. Reverse faults, dips greater than 45 degrees, and thrust faults, dips less than 45 degrees, occur in compressional environments. In mountainous areas such as the Alps, the Northern Rockies, and the Appalachians, thrust faults have displaced strata as far as 50 kilometers over the adjacent rock units. The result of this large-scale movement is that older strata end up overlying younger rocks. Strike-slip faults exhibit mainly horizontal displacement parallel to the strike of the fault surface. Large strike-slip faults, called transform faults, accommodate displacement between plate boundaries. Most transform faults cut the oceanic lithosphere and link spreading centers. The San Andreas Fault is a strike-slip transform fault that is located on land and accommodates the northward displacement of southwestern California and the Baja Peninsula of Mexico. The San Andreas Fault and related splinter faults have produced many large earthquakes. Fractures along which no appreciable displacement has occurred are called joints. Columnar joints form when igneous rocks cool and develop shrinkage fractures that produce elongated pillar-like columns. Most joints are the result of brittle failure, when rocks in the outermost crust are deformed.